In this video, we are going to integrate this. We are going to integrate this. So before we can integrate it, we need to complete the square on this bit here. So remember, completing the square, you've done this in high school, it's always going to be half of this. So half of the 4 would be a 2. And then you've got to take away the rubbish because x minus 2 squared, you've got to take away this rubbish here, which will be take away 4, and then you carry the 8 down, and then single number, you merge them together to give you this. Well, complete the square on this bit will then give you this, which I'm expecting you're able to do because you did it in high school. So so now you can put this back into here. So this thing here will then become this. So now to integrate this, your eye should zoom into this bit here. Create your triangle in such a way that this will be true. Well, if you make the opposite to be x minus 2 and the adjacent to be 2, then the hypotenuse will have no choice but to be x minus 2 squared plus 4 and then square root. So so from here, your eye should zoom into here. Create your triangle in such a way that this will be true. So once you've got your triangle, once you've got your triangle, you can see that tan theta would be opposite over adjacent. So times both sides by 2, and then add 2. So that will then take you to here. So dx equals this thing here. So so later on we can put this into the dx. And then if you look at the diagram here, we need to be able to extract this from the diagram. Well, that's this bit here. Well, if you look at secant theta will be hypotenuse over adjacent, would be hypotenuse over adjacent, and then times both sides by 2. So now we've got this thing here, which is this thing here. So we can put this into here. So that's this bit here, and then we can put the dx into here. That will then give you this. So so this whole thing here will then become this. So tidy this up. Hang on. So tidy this up. The two 2's will cancel each other out, and then you've got one secant left. That will then give you this. And we've integrated this many times. I'm expecting you by now to know that when you integrate secant of x, it will give you this whole thing here. Okay, we've done this many times, so I'm expecting you to be able to do this. So integrate this. That will then give us this. So our answer is this, but we don't want the answer in terms of theta, because at the moment we've got secant theta and tan theta. We don't want the answer in terms of theta. So we would go back to our original diagram, and then translate secant theta. Well, secant theta is this thing here. It will be hypotenuse over adjacent. And then translate tan. Tan would be this. Tan would be opposite over adjacent. So that will then give you this. Now this is our final answer, but we want to tidy this up. So same denominator, merge the two fractions together. That will then give you this. And then you've got one thing divided by another. So natural log a over b equals natural log of a minus natural log of b. So that would then give you this. So you meant, well, that would be natural log of the numerator. Take away natural log of the denominator. Well, this thing here is just a constant. It's just a number, and then you've got a c over here. So let's merge this with this and just give it a new name, c2, or well, just give it, well, just call it c. So basically, this is just a number that you don't. Well, you've got a constant here and a number that you don't care about over here. So let's just merge this with this. So that will then give you this. So your final answer would be this. Okay.